beyond the observable universe. Tonight, let your thoughts drift far beyond the stars you know, beyond our sun, beyond the Milky Way, beyond billions of galaxies scattered across the silent darkness. Picture traveling so far that even light, the fastest traveler in existence, can no longer carry news of what lies ahead. At the very edge of the observable universe, the familiar begins to disappear, and one quiet question emerges. What exists beyond the greatest cosmic horizon we can ever see? Is there endless space, countless unseen universes, or something so strange that human imagination struggles to describe it? Tonight, we begin that remarkable journey. Before we can imagine what lies beyond the observable universe, we must first understand what the observable universe actually is. The name itself can be misleading. It does not describe the entire universe. Instead, it describes the portion of the universe that light has had enough time to reveal to us since the beginning of cosmic history. Picture standing alone on a quiet shoreline at night. A powerful lighthouse shines in the distance, but thick fog surrounds you. No matter how bright the light is, you can only see as far as the beams have managed to travel through the mist. Beyond that invisible curtain, the world continues. Mountains still rise. Oceans still stretch beyond the horizon. Yet from where you stand, they remain forever hidden. The observable universe works in a remarkably similar way. Every star you have ever seen, every galaxy captured by the James Webb Space Telescope, every quasar, every black hole, every cloud of glowing gas, and every planet known to science exists within an enormous cosmic bubble surrounding us. That bubble extends roughly 46.5 billion light-years in every direction. At first glance, that number seems impossible. If the universe is approximately 13.8 billion years old, shouldn't the most distant objects be only 13.8 billion light-years away? The answer lies in one of the strangest discoveries ever made. Space itself expands. When we imagine traveling across the universe, we often picture galaxies moving through empty space, like ships sailing across an endless ocean. But that picture is incomplete. Galaxies are not simply moving through space. The fabric of space itself is stretching between them. Picture tiny dots drawn on the surface of a balloon. As you slowly inflate it, every dot moves farther away from every other dot. None of the dots are actively driving away. Instead, the surface beneath them is expanding. Our universe behaves in much the same way. For billions of years, the distance between galaxies has been increasing because space itself continues to grow. While ancient light traveled toward Earth, the universe never stood still. It expanded every moment of the journey, carrying distant galaxies even farther away. That is why the edge of the observable universe is not merely 13.8 billion light-years away. The continual stretching of space has increased those distances dramatically, placing the most distant visible regions nearly 46 billion light-years from us today. Nothing in everyday life prepares us for an idea like this. Our brains evolved to understand forests, rivers, mountains, and familiar landscapes. We instinctively think of distance as something fixed, yet on the largest scales imaginable, distance itself changes over time. The universe refuses to obey ordinary intuition. Every second, countless photons begin extraordinary journeys across unimaginable distances. Some left their galaxies before our own sun was born. Others started traveling long before Earth even existed. Many have crossed expanding oceans of space for billions of years before finally arriving inside the mirrors of modern telescopes. When astronomers observe these ancient beams of light, they are not simply looking across space. They are looking back through time. The farther we look, the younger the universe appears. Nearby galaxies reveal a mature cosmos filled with heavy elements, complex stars, and planetary systems. Farther away, galaxies become smaller, younger, and more chaotic. Continue even farther, and stars themselves begin to disappear from view. Eventually, the universe grows so young that galaxies no longer exist at all. Beyond that lies a glowing wall of ancient radiation known as the cosmic microwave background. Astronomers often call it the oldest light in the universe. This faint microwave glow has traveled through space for nearly the entire age of the cosmos, carrying with it a snapshot of a universe only about 380,000 years old. Before that moment, the universe was not dark. It was too bright. Matter existed as an intensely hot plasma where light could not travel freely. photons scattered endlessly in every direction, trapped inside a dense sea of charged particles. Only after the universe cooled enough for atoms to form could light finally escape into the expanding cosmos. That ancient light still surrounds us today. It arrives from every direction with astonishing uniformity, quietly reminding us that the universe once existed in a state unimaginably different from the one we know. And yet, even this oldest visible light marks only the limit of what we can currently observe. It is not the beginning of reality, it is simply the earliest chapter that light has allowed us to read. This distinction changes everything. Many people imagine the observable universe as a giant sphere floating inside empty nothingness, but the observable universe is not a physical boundary. There is no invisible wall waiting at its edge, no cosmic cliff where space suddenly ends. Instead, it is a horizon. Standing on Earth and looking toward the sea offers a smaller version of the same limit. Your vision eventually reaches an edge. Ships disappear below the curve of the planet, not because they have ceased to exist, but because your perspective cannot reach any farther. The universe presents us with a similar limitation. There may be galaxies beyond our observable edge, entire clusters of stars, vast cosmic structures larger than anything we have ever detected. They may be astonishingly beautiful, unimaginably strange, or nearly identical to our own region of space. We simply cannot see them, not because they are hidden behind an obstacle, but because their light has not had enough time to reach us. Some regions may never become visible at all. As cosmic expansion continues to accelerate, parts of the universe are receding from us faster than light can bridge the growing distance. Their ancient photons may forever remain beyond humanity's reach, no matter how advanced our technology becomes. A quiet sense of humility comes with that realization. Everything our species has ever observed, from the smallest atom to the largest known galaxy cluster, exists within only a tiny window of a much greater reality. Our greatest telescopes are not revealing the whole universe. They are revealing only the portion that time has allowed us to witness, and that raises an even deeper question. If the observable universe is merely our visible neighborhood, what unimaginably vast reality lies beyond that distant cosmic edge? What lies beyond now? That we understand what the observable universe truly is, we arrive at one of the greatest mysteries in all of science. What lies beyond it? The honest answer is both simple and extraordinary. We do not know. Yet within that uncertainty, modern physics offers several remarkable possibilities. None have been proven. Some are supported by mathematical models. Others emerge from observations of the universe itself. Together, they form a collection of ideas that stretch the limits of human imagination. The first possibility is also the simplest. Beyond the observable universe, there may simply be more universe. Picture standing in the middle of an endless desert. Wherever you look, the landscape appears to end at the horizon, but as you walk forward, the horizon moves with you. It was never a real edge. It was only the limit of what you could see. Many cosmologists believe the observable universe may work in exactly the same way. Our cosmic horizon could simply be a temporary limit created by the finite speed of light and the age of the universe. Beyond it, galaxies may continue for trillions upon trillions of light years. New stars may be forming, massive black holes may be growing, entire galaxy clusters could exist in regions forever hidden from our view. If this idea is correct, then our observable universe is not the universe itself. It is merely one tiny window into something vastly larger, perhaps unimaginably larger. Some estimates even suggest that the entire universe could be hundreds, thousands, or even infinitely larger than the region we can observe today. The word infinite is difficult to understand because nothing in ordinary life prepares us for it. Our minds are comfortable with very large numbers, millions, billions, trillions, but infinity is not simply an enormous number, it has no end. If space truly extends forever, then every direction continues without a final boundary. No wall, no edge, no last galaxy, only an endless ocean of stars and darkness stretching beyond comprehension. Yet infinity introduces an astonishing consequence. If the universe is truly infinite, and matter is distributed according to the same physical laws everywhere, then somewhere beyond our horizon, there may exist another galaxy, almost identical to the Milky Way, farther still, another Earth, and perhaps another version of you. Not because of magic, not because of parallel dimensions, simply because, in an infinite universe, every possible arrangement of atoms may eventually repeat. The thought feels almost impossible to accept. Somewhere beyond distances so vast that even numbers lose their meaning, another person might be looking into their night sky, asking exactly the same questions we ask today. Whether such cosmic duplicates truly exist remains unknown, but mathematics refuses to dismiss the possibility. The universe often proves stranger than our instincts allow. There is another possibility. What if the universe is not infinite at all? Sailors thousands of years ago believed they could eventually reach the edge of the world. Yet no matter how far they traveled, they never found one. Instead, they eventually returned to where they had begun. Earth has no edge because its surface curves back onto itself. Physicists have long wondered whether space itself could behave in a similar way. The universe may be finite but unbounded. In such a cosmos, traveling in one direction for an unimaginable amount of time could, in theory, eventually bring you back to your starting point. There would be no wall waiting at the end of space. Instead, space itself would curve in dimensions far beyond everyday experience. The idea sounds almost impossible, yet Einstein's theory of general relativity allows space itself to bend, stretch, and curve under the influence of energy and matter. Gravity is not simply a force pulling objects together, it is geometry. Mass tells space how to curve. Curved space tells matter how to move. On the scale of planets, stars, and galaxies, we observe this curvature every day. Light bends around black holes. Galaxies distort the images of more distant galaxies through gravitational lensing. Entire clusters of galaxies warp space like enormous cosmic magnifying glasses. If local regions of space can curve, could the universe itself also possess an overall shape? Scientists continue searching for clues. So far, observations suggest that the observable universe appears remarkably flat. Measurements of the cosmic microwave background indicate almost no detectable curvature across the largest distances we can measure. But almost flat does not necessarily mean perfectly flat. The true shape of the entire universe may simply be too enormous for us to detect. Stand on a perfectly calm beach, and the earth beneath your feet looks completely flat. Yet from space, our planet is unmistakably round. Perhaps our observable universe is simply too small, a piece of a much greater cosmic geometry. Then comes an even more fascinating possibility: inflation. According to one of the leading theories of modern cosmology, the newborn universe experienced an unimaginably brief period of explosive expansion during the first tiny fraction of a second after the Big Bang. During this instant, space expanded far faster than the speed of light, not because objects were breaking Einstein's laws, because space itself was expanding. This event may explain why the observable universe appears so smooth and uniform today. But inflation also leads to a remarkable implication. If inflation occurred once, could it still be happening elsewhere? Some physicists believe the answer may be yes. Instead of ending everywhere at once, inflation may have stopped only in certain regions. Each region became its own expanding universe, with its own stars, galaxies, and cosmic history. Meanwhile, inflation continued beyond those regions, endlessly creating new cosmic domains. This concept is known as eternal inflation. If correct, our observable universe could be just one tiny bubble floating within a much larger cosmic ocean. Beyond our horizon might exist countless other bubble universes, each separated by distances so immense that no signal could ever travel between them. Some may follow the same laws of physics we know. Others may not. The strength of gravity could differ. The masses of elementary particles might change. Chemistry itself could work differently. Stars may burn with unfamiliar colors. Or perhaps, in some universes, stars never form at all. These ideas belong to the frontier where cosmology meets theoretical physics. They are fascinating, they are mathematically compelling, but they remain unconfirmed. Science has not yet crossed that horizon, and perhaps that is what makes this mystery so captivating. Every generation has believed it stood near the limits of knowledge, yet history tells a different story. Each time humanity pushed beyond one horizon, another appeared farther away. The edge of the solar system became the beginning of the Milky Way. The edge of our galaxy became the gateway to billions of others. Now, the edge of the observable universe challenges us once again, not with answers, but with an invitation to keep wondering, to keep questioning, and to remember that the greatest discoveries in history often begin with a single quiet thought. What if there is still much more waiting beyond what we can see? Will we ever know? As we stand at the edge of everything we can observe, another question naturally begins to emerge. Will humanity ever discover what truly lies beyond the observable universe? It is a question that challenges not only our technology, but the very nature of reality itself. Throughout history, every generation has believed that it was approaching the limits of knowledge. Ancient civilizations thought the stars were fixed lights attached to a celestial sphere. Centuries later, astronomers discovered that those stars were distant suns. Then we learned that our sun was only one star among hundreds of billions inside the Milky Way. Soon after, Edwin Hubble revealed that the Milky Way itself was only one galaxy among countless others. Each discovery expanded our understanding of the cosmos, replacing certainty with something even more extraordinary, a larger universe. Today, once again, we find ourselves standing before another horizon, but this one may be unlike any that came before. The observable universe is not hidden because our telescopes are too weak. It is hidden because the universe itself limits what information can ever reach us. Picture the faint echo of a distant bell. The farther away it rings, the longer its sound takes to arrive. Now picture the bell moving away faster than the sound can travel. No matter how patiently you wait, its final notes will never reach your ears. Something surprisingly similar happens on the largest scales of the universe. Because space continues to expand at an accelerating rate, many distant galaxies are receding from us faster than light can overcome the growing distance between us. This does not violate Einstein's theory of relativity. Nothing is traveling through space faster than light. Instead, space itself is stretching. Like dots painted on that same inflating balloon, galaxies are carried apart by the expansion of the cosmic fabric beneath them. As billions of years pass, more and more galaxies will disappear beyond our observable horizon. Future civilizations, living trillions of years from now, may witness a dramatically different night sky. The nearby galaxies of our local group will remain visible, bound together by gravity, but the countless distant galaxies that fill today's universe will gradually fade from view. Eventually, observers in that unimaginably distant future may see only their own galactic neighborhood, surrounded by endless darkness. Without evidence of the expanding universe, they might never realize that billions of other galaxies once existed beyond their cosmic horizon. In a profound sense, they would inherit a universe that appears much smaller than the one we know today. Knowledge itself would become limited by cosmic evolution. A deeply humbling thought follows from this. We often think that scientific progress inevitably reveals more about reality, yet the universe reminds us that some information can simply become unreachable, not because science has failed, but because nature imposes its own boundaries. Still, scientists refuse to stop asking questions. Even when direct observation becomes impossible, clever ideas often find new paths toward discovery. One possibility involves gravity. Unlike light, gravitational waves are tiny ripples in the fabric of space-time itself. In 2015, humanity detected these waves directly for the very first time. Two distant black holes collided over 1 billion light-years away, shaking space itself. Those faint vibrations eventually reached Earth, where exquisitely sensitive instruments measured distortions thousands of times smaller than the width of a proton. It was one of the greatest technological achievements in human history. But gravitational waves may someday reveal even older stories. Some physicists believe that waves created during the universe's earliest moments could still be traveling across the cosmos today. If future observatories become sensitive enough, they might detect echoes from events that occurred before the cosmic microwave background was released. Such discoveries could offer our first direct glimpse into the universe's earliest fractions of a second, perhaps even into the mysterious era of cosmic inflation. Another possibility lies within the subtle patterns of the cosmic microwave background itself. This ancient light appears remarkably smooth, yet hidden within it are incredibly tiny fluctuations. Differences in temperature smaller than 100,000th of a degree. These faint variations became the seeds from which every galaxy, every star, every planet, and every human being eventually formed. Researchers continue studying these patterns with extraordinary precision. A few wonder whether subtle irregularities might reveal evidence that our observable universe once interacted with regions beyond beyond it, perhaps another expanding cosmic bubble brushed against ours during the earliest moments after the Big Bang. If such a collision occurred, it might have left delicate fingerprints in the oldest light filling the universe. So far, no convincing evidence has appeared, but the search continues. Science often advances through patience rather than certainty. Sometimes decades pass before technology becomes capable of testing an idea that once seemed forever beyond reach, and sometimes the answer remains hidden. This uncertainty can feel frustrating. As human beings, we naturally seek complete explanations. We want final answers, definite conclusions, a map showing where everything begins and where everything ends. Yet perhaps the universe was never designed to satisfy that desire. Its greatest gift may not be certainty, but curiosity. Every unanswered question inspires another generation to explore further than the last. Every mystery invites someone to imagine what has never been imagined before. Curiosity carried our ancestors across unknown oceans. It built telescopes capable of seeing galaxies billions of light years away. It placed spacecraft beyond the planets, landed robots on Mars, and unfolded the golden mirrors of the James Webb Space Telescope millions of kilometers from Earth. None of those achievements began with answers. They began with questions. The observable universe may represent a horizon we never fully cross, or perhaps future discoveries will surprise us once again, revealing entirely new ways of understanding reality. History encourages humility. Again and again, nature has proven far stranger than humanity expected. Black holes were once considered mathematical curiosities. Gravitational waves were once thought impossible to detect. Planets around other stars existed only in speculation. Today, each is an established part of modern science. What extraordinary discovery awaits tomorrow, no one can say. Perhaps the greatest lesson of the observable universe is not about distance, nor about galaxies, nor even about space itself. It is about perspective. Every generation inherits only a small window through which to observe reality. Our responsibility is not to believe we have seen everything. Our responsibility is to look through that window with honesty, wonder, and the courage to admit how much still remains unknown, because somewhere beyond the farthest light we will ever observe, beyond every galaxy we can name, beyond every horizon our instruments can reach, reality continues, silent, vast, patient, waiting for questions we have not yet learned to ask. And perhaps that endless mystery is what makes the universe feel truly infinite, even if, one day, we discover that it is not. So tonight, as the stars quietly shine above you, remember that every point of light is part of a universe far larger than imagination can fully grasp. And beyond the farthest horizon we can ever see, the greatest mysteries may still be waiting, silent, timeless, and wonderfully unknown. Sleep well and keep looking up.